All right, so today we are looking at topic 5.7, multi-step inequalities. And what that means is we're just putting everything we've done with equations in with inequalities, and we're trying to get you to think through the process and understand why we're doing what we're doing. Okay, so look at this first one. 2 parentheses 5y minus 1 is greater than 8. What do you notice different about today's, Katie? Right, we got the distributive property involved now. So we got to do what? 2 times 5 is 10y. 2 times 1 is 2. Greater than 8. Now I'm ready to make my t-chart. We're back at a 2-step inequality from last week. And what do I do first? Add 2. That leaves me with 10y is greater than 10. Now what do I do? Divide both sides by 10. And y is greater than 1. So I'll come over there, click B, put in 1. Why did I not flip my inequality symbol on this one? Big Joe?
Because there was no negative on the 2 parentheses 5y minus 1.
Right, with the variable. Remember, the coefficient with the variable. That has to be negative in order for me to flip my inequality symbol. It was not negative, so I don't flip it on this one. Okay, everybody wrote this down? What? Right, I did divide. 10 divided by 10, right? Nope, still same steps. Get rid of addition, subtraction first, then multiplication, division. All right? Okay, that was an easy one, though. What if we have one that looks like this? And I got my variable on the right side. I flip it because I like my variable on the left, because if you look at all of your options, Logan, if you're not going to do what you're supposed to be doing, then you can leave. We like our variables on the left side, right? So we want to flip the whole thing. Negative 2 parentheses 3x minus 3 parentheses. Now, if I flip that part of the inequality, I'm going to flip my symbol too, right? So it stays open towards the 18 or the negative 18. All right, now what do I do? Remember how to do these, Ms. McConnell?
You know, I would love to try. Would you do like negative 2 times the 3x and then give you negative 6x and
Yep.
negative 2? No.
Yeah.
Oh, okay. Okay.
We're just
and then
distributing, right?
Distributive, right? And then I would do, boy, this is really going back to years ago. Okay, so then, now I do something weird just because.
It's probably what we do too.
I do plus negative.
Yes.
Do you do that? Because if not, I get a little goofed up on that.
Why do you get goofed up? Because negatives and subtractions don't get along, right?
Yeah, yeah.
That's why we always get rid of subtractions when they're in the negatives.
Yeah, but you know what? Can I write something right here?
Sure.
You know, something that always helped me when I learned how, it's all memorization, like from back in 2nd, 3rd, 4th grade, all of that, it's all memorization. So if you have like a...
So wait, you're saying that what we did way back in elementary school prepared us
Absolutely.
for what we're going to use today?
Yeah.
So what we're using today is preparing us for what they're going to use
forever
in high school?
And beyond.
And beyond. Oh, okay.
Beyond high school.
Okay.
So, yeah, so it's...
Just double check and make sure we're not wasting our time here.
Yes, and I'm going to tell you what, you know how I learned it? You know how I learned how to be good at math? I use flashcards. How many of you have used flashcards before? Oh, if you have not used flashcards, you guys, oh my gosh, flashcards are the bomb. I was telling his other class I used to do around the world with flashcards. Do you know what? Okay. Oh, I didn't want to erase that.
It's not erased. There you go.
Oh, okay. I thought you erased my masterpiece. You see, I was a teacher for many, many, many years, but I never had a smart board. So I love teaching on a smart board. So that's why I like to come in now and then. So -2 times 3x, -2 times 3 is -6, and then the x comes out. -2 times -3. I know that 2 times 3 is 6. A negative times a negative gives me a positive. So I've got -6x. Oh, I forgot my plus in here. Plus 6 is less than -18. Okay? Now, what I can do, this is all stuff you did a long time ago when you did like two-step equations. Is that what it's called?
Yep.
So then you've got a positive. I'm going to do this just so it separates that plus a little bit. Is that okay to do it that way?
Yep.
So now, what I really could do here is something called a T-chart.
Yep.
We used to do that when I was younger. Is T-chart still around?
Yep.
Yeah. Okay, so next thing, what we're trying to do here is solve for that x. Am I correct?
Yes.
Okay, so we have to get rid of that 6. It's a positive 6, so to cross it off, we're going to subtract 6 from both sides. So then, here's where it gets a little difficult. And I'm telling you though, if you just remember the rule I told you, you will always get it right. So we know that this crosses off. So now I've got -6x on this side. Okay? And on this side, I've got -18 minus 6. Okay? But I never want to leave that minus. I always put plus the opposite. Now it makes it really easy because 18 plus 6 equals almost. 18 plus 6 is 24. And since they're both negative, the answer is negative. No. 2 negatives equals a negative. Multiplying 2 negatives gives you a positive. Again, that's just rules that you have to follow. Okay, you memorize them. So we got -6x is less than -24. And then on the last thing we do is we divide both sides by the -6. And then that will cross out to give us x by itself. But I'm going to run out of paper. And then okay. He knows. I'm not even going to respond to him. Okay, so I get x by itself. 24 divided by 6 is what? What times 6 gives you 24? 4. So 24 divided by 6 is 4, because 6 times 4 is 24. So we get then x, this would be if it was down there. X is, oh my gosh, what I did. X is less than 4, but now -24 divided by -6. Is my answer negative or positive? Positive? Is that right?
Yes.
Yeah. So x is less than 4. Is that my answer, Mr. Watson?
Is that your
Yes.
answer?
So it would actually be x is greater than 4 because of the negative 6x.
Because when we multiply or divide by a negative, our inequality symbol flips.
The inequality symbol flips. You're exactly right. Good catch. Good catch. I almost had it.
MJ's on top of stuff.
Hey, that's pretty good.
She is a mathematician.
That's pretty good remembering. I mean, you only did this 10 years ago, right? In high school, so.
Actually
13 years ago, okay.
13 years.
Okay.
You made me go crazy when you did it.
Did you hear Jessie? Jessie. Did you hear what she said?
No.
She said.
Okay, we are back. And all right, let's see. No, that one's too easy for you.
This is tough.
There we go.
All right.
This is the hardest one on here.
Okay. Is this the
Well, here's what I always tell them. We've got to figure out where there was a mistake or if there was a mistake. And so in order to do that, you have to work out the problem. You got to work out the problem on your own and then go back and look and see if you agree with their work.
Okay, so, but my question is, do I read this for the reasoning?
You can if you want.
Or is this the problem?
That's the problem, yes.
This is the problem, okay. So, all right, so here, instead of writing it, can I just kind of look at it and talk my way through it or not?
Well,
No, I want to write it, okay, I didn't know.
they need to write it and work it out.
Okay, so write it down, guys, please, write it down, okay?
You guys should all be writing this
I'll
one.
take it from here. I'll take it from here. So there's our problem. So then I've got to go like this. Okay, a little too loud over here. Okay, here we go. Now, just like we did last time, come on, you guys, we can do this. All right? First thing we have to do that distributive thing. So we say 29. Okay.
No, wait.
And I'm going to do a plus and negative.
There you
okay?
go.
All right. So I've got negative 2 times 2. 2 times 2 is 4. And a negative and a positive multiplied by each other gives you a negative. So that, I'm going to do it this way. I'm going to say plus negative 4. Okay. Now I'm going to go plus negative x. Because I want to get all pluses. I don't want to have some minuses, some pluses. You know what I'm saying? Does that make sense? You need to be writing it down, guys. Write down just the things I've got. Negative 2 times negative x. Negative 2 times negative x. Does that make sense that that gives me 2x? But is it negative or positive? A negative times a negative. Positive. So I've got plus 2x. So far, so good? 19. Okay, so is 29 plus a negative 4 the same as 29 minus 4? Yes, it is. Yes, it is. Because see, I could have gone like this and made that a negative. See what I'm saying? So the way I wrote it is fine. All right, so the next thing I'm going to do, I've got 2 of the same things here, which are numbers without the x's. So 29 plus negative 4. Remember the rule. If you're adding, go ahead and put your chair down this way. If you're adding a negative and a positive number, you actually subtract them. Okay, so I've got a positive 29 and negative 4. So I'm really saying 29 minus 4. Okay, so what's 9 minus 4? What is added to 4 to give you 9? 5. See, I do it that way. If I, instead of saying 9 minus 4, I say, well, 9 minus 4, 4 plus something equals 9. I'm reversing it. Okay, so I got 5, and then my 2 just comes down. Okay, so I subtracted those. What number's bigger, 29 or 4? 29. Notice I didn't say what number's bigger, 29 or negative 4. I just said what number's bigger, 29 or 4. Now that I know that this is a bigger number, that's a positive, so my answer is positive. If that would have been negative 29 plus positive 4, my answer would have been negative. Does that make sense? Question in the back.
Oh, well, not really a question, just like something about math. Is like, when you're doing problems like this, you always steal the sign off the bigger number. That's what.
That is a great point. That is a great point. You always steal the sign from the biggest number. So what she's saying is the same thing I was saying, but in a different way. A positive 29, a negative 4. If you're adding a positive negative number ever, you subtract them and take the sign of the you steal the sign of the largest number. Great point back there. So 25 plus 2x is less than 19. So now we're trying to get x by itself. So we got to get rid of this 25, right? So we have to subtract what from both sides? 25. Okay, so 19 minus 25 is the same as 19 plus negative 25. And it doesn't matter that the 19 is first. All that matters is, on this side, well, actually, I'm gonna do, we subtracted this. Remember 2x by itself here, less than 19 plus negative 25. You're adding a negative and a positive, so you're really subtracting them. Okay? Yes, sir.
Negative 6.
So, excellent, Dave. So what he did, guys, is he took 25 minus 19, because you got a negative and a positive. And to do that really quick in your head, you say to yourself, what do I add to 19 to get 25? If I have 19 cents and I want to get to a quarter, I'm going to need a penny and a nickel. I need 6 cents. So my answer is 6. And back in the back, Miss Hoffman, what of these, which sign am I going to steal? Negative 6, because the negative 25 is the highest. Then the last, so now we're down to this. 2x is less than negative 6. So far, so good. X, oh, to get rid of the x, we've got to divide by 2. Divide by 2. Okay? But this is going to give us a negative 3. And explain that to me about how that less than sign is going to flip-flop. Why is that? Make you check.
So if the whatever the variable is on, if that number is negative, then it's going to be net, then the sign's going to be flip-flop. But if it's not, then it stays the same as it was before. So it would be x is less than negative 3.
So on this, because the x is on the positive side, you're saying that it's going to stay like that?
Yes.
X is less than a negative 3, is that correct? But this says x is greater than a negative 3.
That's wrong.
So this is wrong here.
So you look at this and you say, your classmate should have reversed the inequality symbol? No, because the 2 right here in this step was positive, not negative.
That makes sense? I'll be honest with you guys. I remember how to do all this, but I had kind of forgotten that rule right there. I had forgotten how to do that. All right? But I love